Hi, in this part of the video, I'll be walking you through my tiny shell code. Our video will consist of three parts. The first part will be me walking you through the implemented functions in tiny shell. The other two parts will consist of us talking about our issues as to while working towards the assignment, and then the third video lastly will cover us running the trace files. So let's start. As you can see, there's no issue compiling the tiny shell file. Let's go down to our first function, evaluate. So as you can see, there are some variables initialized. Then we have some sets. Then we have sig empty set, which sets an empty signal set, and then we have sig add new set to sig int. Okay, and then we have sig add set new set to sig stop. These adds the new set signals to sig int and sig stop respectively. Then string copy, so we have a buffer buff that copies the CMD line, and we get the number of arguments from parse line. If the number of arguments is greater than 1, and big G has an ampersand, then big G is 1. If it does not have it, it's 0. Basically, that's what this line does. If it's big G, then we remove the ampersand by setting the ampersand to none. If the number of variables is 0, we do nothing. Okay, then we do sig cross mass, sig block, new set, old set. If not in both in CI and D, then we fork the child process, and then we put a mask on the child process, and then we signal sig int and sig ing. If sig pg, so if the id returns less than 0, that indicates an error and the code did not operate properly. Then we have signal sig int, we call the handler. Similarly, again, if xcvmp returns less than 0, then we make the appropriate print calls and exit. Similar for PID, we do the PR, call users, and exit. If not background, so then it's a for job, so we add the job, process the mask, and over here we handle PR. This is the else case, meaning it's a background job. Similarly, we process the mask and add job, then print the appropriate job, indicating it's been done. Then we have a verbose mode for the v flag, which gives us a little more information about the function. So now we have the do fg. So basically this function checks if the built-in function is used, such as jobs, fg, bg, and quit. And we have the appropriate comparisons, ampersand to tell us it's bg, and job id or 222. Okay, fgd get g. If this does not work, then we just print no job. If this does not work, then we print PID process. PID a toy. This gives us the integer. No such process. So basically, these are the cases where it doesn't work. This is the case where it works. 222 0, and if it's a foreground, we call wait fg to wait until it terminates. its background, then we wait until it's done. Turn. Wait FG, this function basically checks for the PR. This tells us if it's not a foreground, then we just delete the job. And this is just an infinite loop which stays in the loop until the job status changes from foreground to something that's not foreground, and then we return one indicating success. This is sick child handler. Basically, it handles any child processes that are about to terminate or stop. So if it returns 0, that means it'll do nothing. Here we have some variables, int, and then to return the process ID. Get the process ID from wait PID. The struct child job from get PID. If it's -1, that means it's failure. Else if it's a zombie child, we kill it to prevent zombies from being made in the code. Scene handler, this is basically when we use Control-C, and if there's initially we check if there's a job. If there's no job, we return without doing anything. If there's a job, we kill it, and then we print, basically saying printing by updating the status for the job and printing its ID. Just for good practice. This one, similar to the top one, but this is for Control Z. We do the same case. If it's 0, we do nothing with it, but if the process is valid, then we kill it and change its state to stop, and we make a similar print call as above. That covers all the functions, and my part's done. Thank you for listening.